Hello and welcome to this lesson about graphing quadratics in vertex form. The learning target for this video is interpreting and using vertex form to graph quadratic functions. So first of all, let's talk about the different forms that we've encountered with quadratic functions. We have standard form, which is ax squared plus bx plus c. We've seen a little bit of factored form, which is a variation of standard form, where we just have something, we have like x plus or minus something times x plus or minus something. And this is really useful for being able to find the roots, and then you FOIL it all out, and then you're right back to standard form. And so those are two forms that we've encountered. Finally, I want to introduce you to this new form, which is supposed to make our life a lot easier, because the one point that you have to have when you're graphing a quadratic function is that vertex. And so it'd be really cool if we had a form where it told us what the vertex was. And we actually have that, and it's called vertex form. So that is, let's go here to new color, f of x is equal to a times the quantity x minus h squared plus k. Now here's the thing. These guys are just normal variables, run-of-the-mill, okay? And they're going to be replaced with numbers, all right? And then the other thing we need to take from this, I'm going to write this in red, is that the vertex is going to be, now watch this, h comma k. Notice how we lose the negative sign there, all right? Or the sign's going to be the opposite of whatever is in here. It'll be the opposite for the x right there. And as we do some examples, we'll see that. And so what's cool is that we have the vertex, and then we can start to use some of the other tactics we have for finding more points. So again, we got to remember, well, first let's rewrite it all down here. F of x is equal to a times the quantity x minus h quantity squared plus k. And the vertex is going to be at h comma k. So a couple of things we can do to find more points. The first one would probably be our a trick. Now for the most part, a is just going to be 1, but every now and then we'll see other numbers. It might be -1, it could be 2, -3, stuff like that. But the a trick still works because guess what? We still have a. Number 2, we can FOIL and combine like terms to get to c. So if we just FOIL that out, distribute a, add k, we can get c. And then finally, another option that we have would be to set equal to 0 and solve. And if you take a look at this, this form might look a little bit familiar when we would do stuff like x plus 3, quantity squared, minus 4 is equal to 0. And I said solve it. That's solving by taking square roots. And that's why we did that, so we could use vertex form at this point. Okay, enough yakking. Let's do some actual math here. Let's do some examples. So for our first one, let's go f of x is equal to the quantity x minus 3 squared minus 9. Okay, now, first thing, it tells us the vertex. We don't have to do any work for the vertex, which is awesome. So my vertex is going to be at the point 3, comma, -9. Again, notice how the sign changes from there to there. So 3, -9. So 1, 2, 3, -9, right there. That's my vertex. Now, find some other points. Well, I can do the a trick. That doesn't do me too much good. There's that and there's that. And here's the thing. If we can, we want to be as precise as possible on the x-axis. We don't want to just kind of like go woo, because we could also go woo like that. And those are two very different lines. The line is supposed to be a picture of our solution. So what I'm going to do is take quantity x minus 3 squared minus 9, set that equal to 0. I'm going to add 9 to both sides, so I have x minus 3 squared is equal to 9. take the square root. Remember, we have two answers here. So I can have x minus 3 is equal to 3. X minus 3 is equal to negative 3. And with that being the case, x equals 6, x equals 0. 0, 6. Now I know precisely where this line's going to go. Connect them. Boom. And there we go. So that's one example. Let's do another one. This time let's mix things up a little bit. Let's go with f of x is equal to 2 times the quantity x plus 2 quantity squared plus 1. All right, so again, we want to be able to extract the vertex. The vertex is just going to be negative 2 comma 1. So right there, again, notice the change of sign from here to there. All right, now here's the catch. My parabola is going to be going up like that. It's not going to have any x-intercepts. So I can't do the thing where I set it equal to 0. So I got to think on my feet, what are some other options I have for finding more points? Well, I still have the A trick. And so it's 2. I'm going to go up 2 over 1 right there. Axis of symmetry, I have a second point on the other side. So I've done my A trick. And then let me show you how to expand this out. So what I'm going to do is expand this x plus 2 times x plus 2. That's all being times by 2 plus 1. So remember, when we're squaring something, we have to write it out twice. So I'm going to have 2 times the quantity x squared plus 4x from 2x plus 2x plus 4 plus 1. Distribute all of this. I have 2x squared plus 4x plus 8, plus 8x plus 8, plus 1. Keep going one step further, 2x squared plus 8x plus 9. I've now found C. It's at 9, which is right there. And then I can mirror line it, or axis of symmetry. There we go. Connect all my dots as best I can. And there we go. I came up with the graph. All right, I have one more example, and I saved the hardest one for last. All right, so we have negative 3 times the quantity x plus 5 squared plus 3. All right, so again, start off by finding the vertex, and that's going to be at negative 5 comma 3. Negative 5, 3 right there. Looking at A, it's negative, so I'm going to do the A trick. We don't always have to write out A trick. You can just start plotting, but I'm just trying to show you the colors again to show you where I'm getting these points from. So I'm going to go down 3 over 1, down 3 over 1, using the axis of symmetry there. That also happens to be my x-intercepts because that's crossing the x-axis. So I would have gotten the same thing had I set that equal to 0. You might be thinking like, well, wait a minute, Mr. Wagevich. You would have negative 3 x plus 5 quantity squared is equal to negative 3. You can't do that. But when you divide by negative 3, this becomes x plus 5 squared is equal to 1 that you can't take the square root of. So that is fair game. And if you did that, again, you'd get these two numbers right here, negative 4 and negative 6. All right, and then just to continue to show you more, at this point in time, like you'd be good to kind of draw your parabola lines if you wanted, but let's actually... Yeah, you would be, because the y-intercept is going to be huge. But let's just to kind of make a point here. Let's show you how to find the y-intercept. So again, we'd have negative 3 times, and then I'm going to, in my head, well, I won't do my head, I'll write it all out. X plus 5 times x plus 5 plus 3. So do this part, I'm going to have negative 3 times x squared plus 10x plus 25 plus 3. Now here's the thing. I only really care about C because I want to know where this thing crosses the y-axis. So what I'm just going to do is go straight to the chase here and go negative 3 times 5, negative 75 plus 3, negative 72. Not really on my graph, so I can't show that. But again, it's another option out there if we needed it. Anywho, final step, connect, draw, boom, done. There we go. So again, just to kind of recap everything here, Vertex form removes all that negative b over 2a stuff. You're given an equation or the function in a form that tells you the vertex by looking at it. You take that number, you got to change the sign on the x number, but you keep the one on the y number. That's your vertex. After that, you try to find some more points however you can. So hopefully this makes a little bit of sense to you. Good luck on your homework or practice, and let me know if you have any questions.